The Mind of a Crow, Making Friends with the Flying Monkeys in My Backyard. The birds are noisy in Australia. The kookaburra is arguably Australia's most famous noisy bird. She begins her call with a low, soft chuckle, but then she suddenly throws her head back and lets out a loud, infectious laugh. This ruckus sound is usually an invitation for others to join in. They sure do make a racket, but it is a joyous clamour I feel lucky to hear almost every day. The kookaburra easily wins the title of my favourite bird call. If you've never heard a kookaburra laugh, here's a little recording. The birds I hear most often are crows. They don't sound nearly as nice, but what crows lack in musical talent, they make up for in intellectual prowess and curiosity. They are one of the smartest birds around, arguably smarter than the famous intelligent African grey parrot. A few weeks ago, I noticed a crow tossing a nut around, trying to crack it open by throwing it on the ground. It wasn't working, so I decided to help. I took a hammer to the nut while the crow watched from the treetops. With the nut cracked, I went inside to watch and wait to see what would happen. It took them a few minutes, but eventually the crow came down and ate the nut. The next day, next to the water bowl, there were 3 nuts. I cracked them open too. But this got me thinking. I knew crows were smart, but it had been a while since I'd read any crow research. So this week, I decided to get curious about the world of crows. I caught up with some of the latest research, and I spent some time observing the crows in my backyard. I even made them some food puzzles. In hindsight, feeding the crows might not have been my brightest idea. You probably didn't need hindsight to figure that out, but apparently I did. Anyhow, I thought I'd share footage from my backyard experiments and the surprising things I discovered about my new backyard friends. I was interested in 3 main questions. 1, how intelligent are crows? 2, what makes a crow's brain special? And 3, can we detect consciousness in crows? Question 1, how intelligent are crows? Crows are surprisingly brainy birds. On most accounts, they are the smartest of all the birds. In fact, some playfully suggest that crows are better described as flying monkeys than birds. In urban environments, crows have been seen dropping nuts onto busy roads, waiting for passing cars to crack them open, and then swooping down during the red lights to retrieve their snack safely. Crows can also recognize individual human faces, and they seem to hold grudges. If a person is mean to a crow, that bird might harass that specific individual for years afterwards and even teach other crows to do the same thing. And how do crows harass humans, you might wonder? Well, anecdotally, they have been known to execute targeted airstrikes at specific car windows. The crow research blew my mind. These birds show an impressive range of cognitive abilities. Earlier this year, a paper was published in Science suggested that crows can count. They can figure out puzzles that require understanding relationships between different objects or ideas, and they seem to understand some basic principles of physics. For example, when food was placed in a narrow tube half filled with water, the crows dropped stones into the tube, raising the water level and bringing the floating food within reach. Understanding water displacement is a concept that many young children find challenging. You've probably heard of the marshmallow test, that famous experiment in child psychology. In this test, children are given a choice: eat 1 marshmallow now or wait and get 2 marshmallows later. It's a test to measure self-control and the ability to delay gratification for a bigger reward. Well, it turns out that crows can pass a similar test. In experiments, crows were given a choice. They could choose a tool or they could choose an immediate food reward. The tool would help them open a box that contained a high-value food reward, but they would have to wait 10 minutes before they were permitted to open the box. The immediate food reward was less desirable than the food in the box. Of the crows that were tested, many chose to wait with the tool over the immediate food reward. Even more impressive is that the crows did this even when other crows were around who might compete for the food. Crows are highly social animals with complex communication systems. They use a variety of calls and gestures to convey different messages, from warnings about predators to announcements about food sources. Their vocabulary is so sophisticated that some researchers believe that crows have regional dialects. Even more impressively, crows have been known to mimic human language. In one amusing case, a crow in New England learned to say, "Here, boy, come on, boy, let's go." It then used this phrase to round up the neighborhood dogs. These cognitive feats are impressive, but of all their talents, crows are probably best known for their extraordinary tool use and problem-solving skills. Tool use. For a long time, scientists thought that tool use was a key sign of intelligence in animals, but it turns out that even insects and fish use tools. So now scientists focus on how animals use tools rather than simply whether they do or they don't. Insects and fish seem to use tools in a fixed way, but crows are different. They learn to use tools flexibly. They problem solve and learn new techniques on the go. Some evidence even suggests that crows might teach these tool using skills to each other. What's truly remarkable is how crows make their own tools. They craft a variety of tool types, including straight sticks, hooked twigs, and tools made out of leaves. These clever birds don't just make tools on the spot. They carry their tools with them when they search for food. They seem to plan ahead for future use. Even more impressively, crows can create compound tools, a skill once thought unique to humans and some primates. They can combine sticks together to make a longer tool, or they can use one stick to retrieve another, more suitable tool, which they then use to reach food. Crows don't simply use tools in a fixed way like fish. They seem to grasp the concept of tools as a problem-solving device. But is tool use in crows really a sign of intelligent problem solving, or is there a simpler explanation? Problem solving. When scientists study tool use in animals, they often are interested in whether the animal understands cause and effect relationships. For example, does a crow know a hooked stick can pull food closer because of its shape, or is it just copying what worked before? Researchers want to determine if animals come up with solutions based on understanding how things work, or if they learn purely by trial and error, trying things repeatedly until they succeed. This distinction is crucial because it helps us gauge how deeply animals comprehend their tools and the problems they're solving. To investigate this, scientists like to give crows new problems that are similar to what they might face in nature, but different from what they've seen before. If crows truly understand how their tools work, they should solve these new problems quickly. But if they're just relying on trial and error learning, it might take them longer to figure things out. One experiment tested whether crows could pick the right tool for a new job. Scientists gave crows, Betty and Abel, 10 sticks of different lengths and put food at various distances in a clear tube. The results were impressive. The crows chose the appropriate tool from the start, selecting shorter sticks for closer food and longer sticks for food that was further away. In another experiment, Betty demonstrated an even more impressive feat. When she was given a task that required a hooked tool, she tried with a straight wire, but after a few failed attempts, she bent the wire into a hook, which she then used to retrieve the food reward. The ability to select appropriate tools for novel tasks seems remarkable, but scientists caution that while this behavior suggests crows are selective and flexible, it doesn't necessarily mean they understand cause and effect in the same way that humans do. Despite the scientists' caution, YouTube is full of videos demonstrating crows' astounding problem-solving abilities. I've included a video of a crow tackling an 8-step puzzle. You'll find it in the article. This crow in the clip is a New Caledonian crow, considered the smartest of all the crow species. This crow was kept in captivity where it could learn from humans and become comfortable with them. It's unlikely that my wild backyard crows would measure up to the crow's problem-solving skills in the video, but I did wonder how the neighborhood crows would handle a simpler challenge. So I decided to set up a not-so-scientific experiment of my own. On a stepping stone, I placed 4 pieces of food. 2 pieces were out in the open and easy for the crow to reach, and 2 pieces were inside a clear tube, 1 at each end. 1 piece was near the edge of the tube and it was easier for the crow to reach, and another piece was pushed deeper inside the tube out of the crow's reach. I left some sticks of various lengths nearby, and after setting this up, I pressed record on my phone and I went inside to watch what would happen. It's not exactly a Hollywood blockbuster, but if you are curious to see what I saw, then you can check out the clip in the article. No sticks were necessary. It seems the backyard crows outsmarted me, at least this time. I decided to make things a little more difficult by wedging the tubes under the stepping stone, but they managed to get most of those too. I never did see them use sticks or any other tool, but I have noticed them noticing me. They seem to track my movements, watching intently wherever I step inside or outside or I get up from my desk. One of the more curious of the crows now walks past my door every half hour or so, pauses, tilts his head and looks at me as if he's saying, "Hey, do you want to play?" Question 2. What makes a crow's brain special? Evolutionarily speaking, the last common ancestor of primates and crows lived about 312 million years ago. Despite this vast evolutionary distance, crows have developed cognitive abilities that in many ways seem similar to primates. There are many parallels between a crow's brain and a human's brain. We both have brain regions responsible for memory and emotion, like the hippocampus and the amygdala, but there are some significant differences too, especially when it comes to the cortex. Crows, like all birds, don't have a cortex in the same way that mammals do. In mammals, the cortex is a distinctive layered structure on the outer surface of the brain. It typically has 6 layers, each with specific types of neurons and connections. This layered organization is often credited with enabling complex cognitive functions in mammals. The bird brain, however, is organized differently. Instead of a layered cortex, birds have a region called the pallium. The pallium isn't layered like the mammalian cortex. Instead, it's arranged in clusters of neurons called nuclei. Despite this structural difference, the bird pallium performs many of the same functions as the mammalian cortex. What's particularly remarkable is that the crow brain has about twice as many neurons as a primate brain of equal mass. While the crow's brain might be small compared to many mammals, it's incredibly densely packed with neurons. This high neural density, especially in areas responsible for intelligent behavior, might explain how crows achieve their impressive cognitive abilities despite having a differently organized brain. Traditionally, we have thought that a layered cortex is necessary for higher intelligence, but the crows are showing us that brains don't need to be built like ours to be smart. Question 3. Can we detect consciousness in crows? We've seen that crows are remarkably intelligent, capable of using tools, solving complex problems, and even understanding analogies. But some remain skeptical about whether these impressive abilities mean that crows are conscious. To tackle this challenging question, scientists used a technique that is often used to test visual consciousness in human participants. The experiment used threshold stimuli. In human experiments, a threshold stimulus is often a very dim light that participants detect only about half of the time. The key feature of threshold stimuli is that the light intensity remains consistent throughout the experiment. Sometimes a participant will see the light, and sometimes they won't, even though the light itself never changes. This setup allows researchers to study how different mental states correlate with different brain activity. If we find a difference in brain activity between when a participant reports seeing the light and when they report not seeing it, we know this difference is due to a change in the participant's mental state and not a change caused by the light itself. The difference in brain activity that responds to a conscious experience is what scientists call a neural correlate of consciousness, or an NCC. In the crow experiment, researchers trained a crow to peck a button when it saw a light on a screen. Sometimes the light was bright and easy to spot, sometimes it was at threshold intensity, and sometimes there was no light at all. After each trial, when the light appeared or not, the crow had to wait a moment before reporting its experience. While the crow performed this task, scientists recorded the activity of individual brain cells in the crow's pallium, that region thought to be involved in complex thinking in birds, much like the prefrontal cortex is in mammals. What the scientists found was fascinating. When the light first appeared, or didn't, the crow's brain cells mostly responded to the physical intensity of the light. But during the waiting period before the crow reported its decision, something interesting happened. The brain cells' activity shifted to match what the crow was going to report, rather than simply reflecting how bright the light actually was. If crows were simply responding to the light's intensity, we'd expect to see consistent brain activity on those threshold trials. After all, the light's brightness doesn't change. But that's not what the scientists found. Instead, they observed different brain activity depending on whether the crow reported seeing the light or not, even though the light itself was identical in these trials. The researchers believe this finding reveals something fascinating. The crow's brain seems to be representing the bird's subjective experience or decision, not just responding to the physical light. In other words, they think this shows that the crows, like humans, have inner experiences that go beyond simply reflecting the physical world. Instead, these experiences represent how the crow perceives and interprets what it sees. If the scientists' interpretation of these findings is correct, it suggests something interesting about the evolution of consciousness. Given the last common ancestor of humans and crows lived about 312 million years ago, we're left with two intriguing possibilities. One, consciousness evolved independently in birds and mammals. Or two, consciousness, at least in a basic form, already existed in our common ancestor long before humans or crows existed. Either way, the researchers suggest these findings challenge the assumption of unique human consciousness, hinting that subjective experiences might be widespread in the animal kingdom. While these findings are fascinating, not everyone agrees with the researchers' interpretation. There is an ongoing debate in the scientific community about what exactly neural correlates of consciousness measure. Do they truly indicate conscious experience, or are they more reflective of other cognitive processes? But that's a whole discussion for a whole nother article. Thank you so much for listening to this article. I want to take a small moment just to say thank you so much for all of the lovely comments and interaction that we have here on Substack. It's really incredible. I'm enjoying myself a lot, and I really hope you are too. And if you would like to support my work in more tangible ways, you can do that in two ways. You can become a paid subscriber, or you can support my coffee addiction through the Buy Me a Coffee platform. For those of you who have decided to support my work financially, I just want to say a really big thank you so much. Your support means the world to me. So thank you.